In this session, I will discuss the questions related to topic chemical energetics. In the last session, I have discussed first 8 questions, and today I will discuss eight onwards. So, in question 9, the enthalpy change of formation are often difficult to determine directly. Some enthalpy data are shown. The standard enthalpy change of formation for water is given in a liquid state, that is minus 285.8. And enthalpy change for formation of carbon dioxide in a gaseous state is given 393.5. The standard enthalpy change of a combustion of propane is minus 2219 kilojoule per mole. Add arrowhead and stoichiometric coefficient to Hess law diagram. So here, because the formation is given, so when the formation is given, it means that element will form a compound. We have the formation of water and we have formation of carbon dioxide. So when we relate or draw an arrow or complete an arrow, so here hydrogen, but hydrogen mixed with oxygen to form water. So there must be oxygen as well, O2. Same thing, carbon reacted with oxygen to form carbon dioxide, so there must be oxygen as well. And the combustion is given, the combustion of propane is given, that is minus 2219. So we should draw an arrow is already there. And same thing, this is the formation of a propane, because when element form a compound, and then there should be a combustion of propane as well. So this is a combustion of propane. Then the balance equation for this, how we'll write a balance equation? Simply, if you want to balance the equation for combustion, like we have C3H8 and it is forming, so C3H8 reacting with oxygen to give carbon dioxide and water. So to balance the combustion equation, we start with carbon followed by hydrogen at the last oxygen. So carbon 3, so we put 3 carbon is balanced. Hydrogen, we have 8, 2 are already there, so we put 4 multiplied by 2, that make 8. And what about oxygen? 3 multiplied by 2, 6, and plus 4, that is 10. So we need 10 oxygen, so we'll write 5 O2. So for both equations, we'll have 5 O2, and here the coefficient will be 3, and here the coefficient will be 4. Then how many moles of water are formed here? You can see 4 moles of water are formed. So this will be 4 times the formation of water in a liquid state. So 4 multiplied by minus 285.8. And we produce 3 moles of carbon dioxide. So this should be 3 multiplied by minus 393.5. And burning 1 mole of a propane, when we burn 1 mole of a propane, the energy here, so the total energy will be minus 2290. So according to his law, where the 2 arrows are pointing out, that is the start of the cycle. So we'll have this as a start. And where the 2 arrows are pointing in, that is the end of the cycle. So the 2 arrows are pointing in, that is the end of the cycle. And overall energy change, according to Hess law, the overall energy change does not depend on the route or the path which we follow. So if we follow path 1, like this is our path 1, if we follow path 1 or we follow path 2, the overall energy change does not depend on the route or the path which we follow. So combustion of propane is given negative, as well as the formation of water, as well as the formation of carbon dioxide. because these are negative sign shows it is an exothermic reaction. So what we are finding, according to the question, what we have to find, we have to find the formation of a propane. So this is a formation of a propane. So this is unknown. So this is X. So when we apply the cycle here, the Hess law cycle, as the overall energy change is independent of the root, so the equation will be X. This one is X plus, so this is X plus, and the energy for combustion, that's this region because we are following path 1. So it is minus 2219. That is equal to the second root. So this is the second root in which the energy change is 3 times the combustion of carbon dioxide, so which is 393.5 plus 4 molecules of water are produced, so it will be 4 times minus 285.8. So we are finding this X, will move the number other side. So 2000, this will be positive other side. When we solve this, the value of X will come out as 104.7, and it is negative kilojoule per mole. Next question. In part B, the value for a boiling temperature and the standard enthalpy change of combustion of series of a straight chain alkane is shown. Like ethane is there, then propane, butane, pentane, hexane, and heptane. The boiling temperatures are given as well as the enthalpy change of a combustion. You can see a similarity approximately like 700 differences there, approximately, not exactly, but approximately like 700 difference between the consecutive members. So explain why the increase in enthalpy change of combustion are similar. So why increase in enthalpy change of combustion is similar? When you draw the structure of ethane, eth means 2 carbon and then 6 hydrogen will be there. Prop means 3 carbon and 8 hydrogen. And but means 4 carbon atoms and 10 hydrogen. So what is the bond difference? When you check the bond difference here, we have 1 carbon-carbon bond and we have 6 carbon-hydrogen bond. Here we have 2 carbon-carbon bond and we have 1, 2, 3, 4, 5, 6, 7 and 8. So the same number of bond difference is there. Each member differ by CH2, but because we are finding or we are explaining a reason why there is a similarity in the combustion, enthalpy change of combustion. So what is the reason for that? When you check that, you will find each member will have a same difference of CH2. So as each member differ by CH2 or the same number of bond differences there between the successive members, so bonds which are breaking, so bonds broken and made each member differ by CH2, that's why the same amount of energy change occur, almost same amount. It's not exactly the same, So each alkane differ by the other alkane CH2, and same number of carbon-carbon bond and same number of carbon-hydrogen bond forms a homologous series, and it is having a general formula of CnH2n plus 2. So the answer here, why there is a similarity? Because each member differ by CH2. So similar bond difference leads to same difference in enthalpy change of combustion. The increase in the value of enthalpy change of a combustion for butane to pentane is smaller than any other increase. So when we check butane to pentane, this is butane and pentane, it is relatively smaller. What could be a reason for that? So the main reason, when you work out the state, because normally the first four members are in a gaseous state. So why we find this difference here? Because at room temperature, the reason they give you the boiling temperature. So example, the standard, if you take a room temperature is 25, so you will find that pentane will be a liquid, but for butane you will find it is a gas at room temperature. So there is a difference in the state, that butane is a gas whereas pentane is a liquid at standard condition around 25 degrees centigrade. And normally liquid, they need energy first to vaporize and then burn. That is why, so some energy which is released during a combustion is absorbed by the vapors, absorbed by the pentane to convert from liquid to gaseous state. Is it clear? What is the reason why there is a small difference? Because they are asking, they mention in the question, the increase in the value of enthalpy change of combustion of butane to pentane is smaller than any other increase. So what is the reason for that? Because butane is a gas and pentane is a liquid. So to burn pentane, first pentane has to be converted into a gaseous or a vapor state. So when we burn, some of the energy which is released during a combustion is absorbed by the pentane liquid in a liquid state to convert into vapors, and then it burns. Next question, question 10, MCQ 10. The energy profile for reaction is shown. So reactants have low energy and the product is having high energy, so it means this is an endothermic reaction. What is the minimum energy needed for this reaction to occur? So they are asking for activation energy from reactant till the point where the reaction starts. That is known as the activation energy. So which label is representing the activation energy? So A is representing the activation energy, or X is representing the activation energy. Question 11. The table shows amount of energy released per gram when some alkanes are burned in excess of oxygen under standard conditions. So energy release given in kilojoule per gram. Which alkane has a standard enthalpy change of combustion minus 2877 kilojoule per mole? This is per gram, like the energy released when 1 gram is burned. But what we have to do, we have to convert and find the moles. So how to find the moles in 1 gram? Like if I have 1 gram of methane, or I have 1 gram of ethane, I have 1 gram of propane, and I have 1 gram of butane. So 1 gram, how many moles are there? So moles equal mass in gram divided by molar mass for methane, which is CH4. So mass in gram is 1, and the molar mass carbon is 12 plus hydrogen is 1 into 4, so that total will make 16. So this will be 1 divided by 16. So 1 gram of methane will have how many moles? 0.0625. Same thing, 1 gram of ethane, the molecular formula of ethane is C2 and H6. So carbon is 12 multiplied by 2, so that is 24, and 24 plus 6, that makes 30. So this will be 1 divided by 30, 0.033. Then for propane, it is C3 and H8. So 1 divided by 36 plus 8, that's equal to 44. So 1 divided by 44, that's equal to 0.022. And for butane, the formula for butane is C4 H10. So 48 plus 10, 58. So 1 divided by 58. So 1 divided by 58, that will give us 0.172. These are the moles, 0.0172. So these are the moles of these gases in 1 gram. And the energy released when 1 gram or this many moles are burned, because we need for 1 mole. So according to this question, if we have 1 gram of butane, or how many moles are there? So 55.6 kilojoule per gram. So 55.6 energy is released when we burn 0.0625. But we need how much energy is released when 1 mole is burned, so it will be X, cross multiply. So basically X will be equal to 0.0. So X will be equal to 55.6 divided by 0.0625. So 55.6 divided by 0.0625, that will give the energy release. So this will release about 889.6 kilojoule per mole. Same thing, this is the energy release per gram, so we'll divide by the mole in 1 gram, that is 0.03. So 52 divided by 0.03, that is equals to 1733 kilojoule when 1 mole is burned. And 50.4 divided by moles of propane, that is 0.022, that's equal to 2290 kilojoule per mole. And 49.6 divided by moles, 0.017, that's equal to 2917, so which is approximately closer to minus 2000, because I did not use the whole complete numbers, that's why I'm not getting the exact 2877. So when we burn 1 mole of a butane, it will release this much amount of energy. So D is the right answer. Is it clear? So basically first we got the moles in 1 gram, and we divide the energy by number of the moles to get energy release per mole. So next question, question 12. The enthalpy changes for two reactions are shown. What is the enthalpy change for dissociation of ethanoic acid into ethanoate ion and hydrogen ion in kilojoule per mole? So what we can do, we can solve this as like a simultaneous equation as well, because we need the dissociation. What is our final equation? We need, like, when ethanoic acid, which is CH3COH, will dissociate into CH3COO and H plus. This is what we need. So we want to cancel out water molecule as well, because we don't need water molecule in the final equation. Well, we don't need OH ions. When they are on the same side, so what we normally do, we subtract the equation. If they are on the opposite side, we add the equation so that we can cancel out. But if they are on the same side, we subtract the two equations. So if I subtract the two equations, so this will be, the sign will change. This will be minus, this will be minus, this will be minus, this will be minus, and this will be plus. Now what will be the overall equation when I subtract the two equations? What we'll get? So the OH ion will cancel with the OH ion, the water molecules cancel with water molecule, and what we are left with, we are left with H plus minus CH3COH, that is on the left hand side, and on the right hand side we are left with CH3CO negative, because the sign changes, so it will be minus. And the overall energy, when we solve this, it will come out as minus 1.2 kilojoule per mole. But this is not our desired equation. What is our desired equation? If we solve, like, this is negative, it will move other side, and this is negative, it will also move to left hand side. So H plus CH3CO gives CH3COH, and that is, again, because we did not completely change the equation, that is kilojoule per mole. But now what we need a reverse equation. We don't want, because in the question we need a dissociation of ethanoic acid into ions. So if ions combine and form ethanoic acid, the energy change is minus 1.2. But if the opposite equation was there, like ethanoic acid will dissociate into ions, then it will be plus 1.2 kilojoule per mole. So the correct answer will be B. Is it clear? In question 13, this is a structure question. This question is about ethanoic acid and some related salts. So in this question, the things are related to ethanoic acid and the salts which are related, and other related salts. A test to confirm the presence of aqueous acid is by adding a small amount of sodium carbonate. So when we add a carbonate to an acid, what we will observe, the first thing, because when acid react with carbonate, it will give carbon dioxide. But you will, in an observation, you will not write carbon dioxide. What you will write, you will say bubbles, effervescence, fizzing. That is what we observe. So we can write fizzing. And the second thing, what will happen, the solid will dissolve. Which solid will dissolve? That carbonate. So we just have to mention what we'll observe when this reaction occurs. The next question, sodium ethanoate is a component of reusable hand warmer. In use, a supersaturated solution of sodium ethanoate recrystallized to form a solid hydrated sodium ethanoate, releasing energy. So recrystallization occur. forming a hydrated salt, and the forward reaction is exothermic, which result in release in energy. That's how it is used as a hand warmer. The hand warmer has a mass of 63.2 gram and forms 20.1 grams of hydrated sodium ethanoate on recrystallization. Calculate the maximum temperature reached by the hand warmer if the initial temperature is 5. The specific heat capacity of the hand warmer is also given, that is 3 joule per degree centigrade per gram. So first, what we will do, we will calculate the molar mass of hydrated sodium ethanoate, and from molar mass of hydrated sodium ethanoate we'll calculate the moles of hydrated sodium ethanoate, and from moles we have the formula E is equals to Cm delta T. We can work out how much energy is released. So basically we have, this is delta H, and what is this delta H? Enthalpy of the reaction, that is energy divided by mole. So if we multiply this, so it will be delta H, the enthalpy change multiplied by moles, we'll get how much energy will be released. And from energy release, we can use this formula E is equals to Cm delta T. We can work out the temperature change, and from temperature change, we can work out the final temperature. So the steps here, first we are finding the molar mass of sodium ethanoate. That is CH3CONA. So carbon is 12 multiplied by 2 plus hydrogen is 1 multiplied by 4 plus oxygen is 16 multiplied by 2, and this is for hydrated. So for hydrated one, this is anhydrous, but for hydrated, that is 3 water molecules are also attached, so that is 3H2O. So the molar mass of hydrated sodium ethanoate CH3COONA dot 3H2O. So carbon is 12 multiplied by 3, 12 multiplied by 2 because H is there, hydrogen 1 multiplied by 4 plus oxygen 16 multiplied by 2 plus sodium is there 23, and plus the 3 water molecule, each water molecule is 18, so this will be 3 multiplied by 18. The sum will come out as 136 grams per mole, or each mole will have this much mass. Then moles of hydrated sodium ethanoate, the moles equal mass in gram. The mass in gram for hydrated is 20.1, and the molar mass is 136, so we'll get the moles which will come out 0.14779, and we know enthalpy change is equals to energy divided by mole, so we'll multiply the energy release will be enthalpy change. The reaction is exothermic, but we are taking a number here for calculation, which is 19.7 kilojoule per mole, but we need energy in joules. When we use this formula, our answer will be in joule, then later we convert. So this will be 19.7 kilojoules, so we have to first convert into joule, multiply by 1000. So this will be 19,700 multiplied by 0.14779. This will give us the energy, which will come out as 2911.5 joules. And after getting this energy, we will use the formula E is equals to Cm delta T. So energy is 2911.5. Specific heat they mention in the question, that's 3. The mass of the total mass, that is 63.2, and the temperature change we are finding delta T. So this will go there in division. So delta T, the temperature change will come out as 15.3. Because the forward reaction is exothermic, so temperature change is T2 minus T1. The temperature change is 15.3. The final temperature we don't know, and the initial temperature was 5. This will move other side, so it will be 20.3 degrees centigrade. That will be the final temperature. So that's why this was having 5 marks, as you have to use 2 different formulas. The next question, ammonium ethanoate is used to control the pH of food. It can be formed by reaction of pure ethanoic acid with ammonium carbonate. Calculate the standard enthalpy change of this reaction by completing the Hess cycle. And the values are given. This is also 5 marks. So as you can see, enthalpy change of formation. When formation is given, the link what we have to add, like here we should have element, because formation is always from element. Here we should have reactant, and we'll have a product. So overall energy change is independent of the route or the path which we follow. That's a Hess cycle. So element form reactant, reactant form product is same as element directly form the product. So we just have to add the links here. So they mention ammonium ethanoate is used to control, and how it is formed. It is formed by reaction of ethanoic acid with ammonium carbonate. So when acid react with carbonate, it will give salt, water, and carbon dioxide. The reason why I'm showing this data as well, so that I can use for calculation. So if I write ethanoic acid is reacting with ammonium carbonate to give ammonium. So ethanoic acid, that is CH3COOH, reacting with ammonium carbonate NH4 in a bracket 2CO3, gives ammonium ethanoate, the salt plus water plus carbon dioxide. The equation must be balanced. So when you check carbon is there, that's balanced. Hydrogen, the overall equation, because we have 2 ammonium ions here in the beginning, but as a product we have only 1 ammonium ion. And we have to add a link here. So first we try to balance the reactant product, then we can add a link for element. This should be 2, and this should also be 2, because 2 ammonium ions are there, and when we put 2 here for ammonium ion, we should have 2 ethanoate ions as well. That's why I put 2 here. Then we have to add a link element. So what are the elements here for this reaction? We have nitrogen. How many nitrogen molecules we need, because the element in the standard state. So the total number of nitrogen is 2, so we just only need 2. Then about hydrogen, the total number of hydrogen, it will be 8 multiplied by 2. 16 hydrogen are there, 4 multiplied by 2, 8. And then this is 4 multiplied by 2, 8. So total 16, so we need 8 molecules of hydrogen. Then oxygen exists as O2, and how many we need? 7. So this should be 3.5, or 7 by 2 you can write, and plus 5. C. Then in terms of energy, because the formation, all the formations are given. So 2 molecules of ethanoic acid are formed. So this should be 2 multiplied by minus 484.5. Then one molecule of ammonium carbonate is produced. So then it should be plus, because the overall energy of this, it will be minus 939.9. Then here 2 molecules of ammonium ethanoate are produced, so this should be 2 multiplied by 586.3 plus 1 molecule of carbon dioxide is produced, that is minus 393.5, and plus 1 molecule of water is produced, that is minus 285.8, and we have want to find this is unknown. So where the 2 arrows are pointing out, that is the start of the cycle. So when you check, the arrows are pointing out, so that is our start of the cycle, the beginning. And where the 2 arrows are pointing in, that is the end of the cycle. So the overall energy change does not depend on the route or the path which we follow. So if we follow path 1 or we follow path 2, the overall energy does not depend on this. So when we substitute these values, our final answer will be, so when we write the equation, it should come out as so if I write the equation, 2 into minus 484.5 plus minus 393.9 plus x is equals to 2 into 586.3 minus 393 and minus 285. So this will give us the final answer as 57 kilojoule per mole, because all the answers, all the values are in kilojoule per mole. So our final answer, this, when we substitute the values, it will come out as 57 kilojoule per mole. As the equation will be, I will write the equation here, because it's, if we follow root 1, so it will be 2 into minus 484.5 plus in a bracket minus 939.9 plus x is equals to 2 into 586.3 plus minus 393 plus minus 285.8. So we get this x, we move other side, so final answer will be 57 kilojoule per mole. Ammonium carbonate is an ingredient in cleaning solution for a camera lens. There are aqueous solution which contain no more than 1.8 gram of ammonium carbonate in 100 cm cube. Calculate the maximum concentration in mole per dm cube. So we have the mass, we'll convert into mole, and we have the volume, but that is in cm cube, we'll convert into dm cube, and moles, the concentration is mole per dm cube. In mole per dm cube, we'll divide moles by the volume to get the concentration in moles per decimeter cube. So 1.8 is a mass in gram divided by molar mass of ammonium carbonate, that will be NH4 in a bracket 2 CO3. So nitrogen will be 14 plus hydrogen 4 multiplied by 2, 14 times 2 plus 1 into 8 plus carbon is 12 plus oxygen 16 multiplied by 3. We get the moles. Molar mass, this will come out as 96, so this will be 0.1875 moles. And the volume, that is given in cm cube, we have to convert into dm cube divided by 1000, so 0.1. So the mole 0.01875 divided by volume as 0.1, it will give us as 0.1875 mole per decimeter cube. This will be the concentration. In question 14, which quantity is exothermic? Exothermic reaction, enthalpy change of atomization. To atomize, you have to supply energy. First ionization, because to remove the electron, you have to supply energy. First electron affinity. When electron is added to a neutral gaseous atom, energy is released. So this is exothermic. So C is the second. Electron affinity is not exothermic. Why? Because already there is charge -1. So to add electron, like charges repel. That's why you have to supply energy. So the second electron affinity will be endothermic. In question 15, the following statements are there as shown. Magnesium chloride is stable with respect to magnesium and chlorine. Magnesium MgCl is stable, unstable as compared to MgCl2 and Mg. And MgCl is 3 is unstable with respect to chlorine and magnesium. Which signs of standard enthalpy change of formation for MgCl and MgCl3 are correct? So MgCl is stable. So if MgCl is stable, it means the reaction should be exothermic, because when we work out that stable, reactant will have more energy and product will have less energy. So when magnesium and chlorine react, they form MgCl, and MgCl is stable means it will have low energy. So the reaction will be exothermic. So this should have a negative sign. And MgCl3 is unstable with respect to, so if it is unstable, it means it has high energy or required energy. So it will be endothermic reaction. So enthalpy change should be positive. So C is the right answer. Is it clear? So when we say the compound is stable, it means it will have low energy. When compound is unstable, it will have high energy. When 10 cm cube of solution mixed with 30 cm cube, 10 cm cube of nitric acid react with 20 cm cube of sodium hydroxide, the solution the temperature change is delta T. Now repeating with 50 cm cube with 30 cm cube, what would be the change in the temperature? So what will be the change in temperature when you check the total volume was 30 and here the total volume is 45. So volume increased by 1.5. And what about the moles? Because this was 10 cm cube, now it has become 15. So moles also increased by 1.5. So the overall temperature change is directly proportional to energy or moles. Moles are increased by 1.5, so temperature change increased by 1.5. And temperature change and volume are inversely proportional. So volume is increased by 1.5 total volume. So temperature change decreased by 1.5. So one factor increasing 1.5, other factor decreasing 1.5. So overall energy, the temperature change will be same. And why I took specifically, because when you write a balance equation, the mole ratio is 1:1. So